Good afternoon. My name is Maximiliano Juarez Gilces, and for my final project of automation, I'm going to present a semi-automatic rotary and grabber. Let's explain the problem. My family has his own escala refaccionar el pistón. This is an auto part shop located in Tapachula, Chiapas. In the last year, we are selling your products in the online platform Mercado Libre. So to send all the products that we sell, then we need to package and to wrap them. But these actions, this process is do it only by hand. So this is a problem because consumes a considerable amount of time and efforts. So for resolve this, I propose the use of this machine, an automatic wrapper, especially arm rotatory type, because this type of machine is better for the proposal that we need, because the machine is good to work with products that doesn't have the stability or doesn't have so much stability. And this is better because we need that the product don't fall or don't move underneath the position to wrap there correctly. Then these machines consist in a motor that controls the movement of the rotatory arm, a cylinder that controls the movement of the roll up and down, and principally the optical absolute encoders that control the movement and stop of the actuators. This type of machine, the absolute encoders, works with pulse signals for a specific positions of the piece. For example, we measure the height of the product with sensors, then the actuator is going to move the roll to that direction, and the encoder is going to send us a pulse with, and every pulse is going to mean one position that is going, and when we want to stop, we want, and when the roll is in the desired position, the encoder is going to send the signal that the roll is in this position and stop the actuator to move. In the same way with the rotatory arm, we can measure not only the position, but even the speed and the direction that is turning the arm. For the we use, I use three applications for simulation. The first is the Autodesk Fusion 360 for a modeling, a first modeling of the machine and how this move in every mode that he have. And for the virtual PLC, I simulate with codices and the Festo Fluid Sim. So this is a first sketch of the design of what with the machine will be. And these machines have three modes. So let's start with the first mode. The first is the up mode. The second mode is the only down mode. Finally, the third mode is the up and down mode. And one additional thing is that the machine have an automatic cutter for the paper, but this only works for the down and the up and down move. This because the cut paper is in the lower of the machine, and when this in the up down, this is going to to finish in the up. So when the machine start to reach to the last lap, the first actuator is going to move to put between the paper and the final lap paper. Then when the final lap the machine reach the final lap, the second actuator is going to press the paper and finally is going to cut this. After that, the three actuators is going to restart to the original position. And then for the virtual PLC simulation, first we have the Festo FluidSync application. So in other hand, here we have your the PLC circuit, and here we control all the process and all the actions that the machine needs to do. The control panel, the selection of the modes, and every action. And here we have your visualization. Here we have that this button is the on of the machine. When I press it, the machine starts to function. Then the and the emergency stop, activate the red LED, and stop the function of the machine. So we need to reset it to activate again. In the same way, this sensor is an emergency sensor that activates when something is blocking the way of the arm. So in the same way, we need to reset to start again the machine. This switch represents the encoder. This is going to show us when the encoder send a signal and when send the final signal to stop the movement of the rod. The button here is the start of the process, and when we press this button, the process starts. This because the adjustment of the paper to the object is doing manually. So when the operator adjusts this paper to the product, press the button to start the process, and finally he have the three modes: the up mode, down mode, and up and down mode. So the machine is on, the mode is select, the encoder is going to be active, and start the process. Then the second mode is going to active the encoder and start process. Then finally, the up and down process, we activate the encoder again, start the process. For final, here we have a Gantt diagram that represents the time that we need to do or when we have to be to and all the actions to develop the machines. First, we have to evaluate the process, the resource that we have, and then with that, design adjustments or a better design for the machine. Then with this completed, we need to select and obtain the mechanisms and all the parts that we need to the construction. Then the time of the development, the creation of the machines is one of the most largest with the development of the software that is going to be do it simultaneously in the final times of the development of the machines. Then the machine is going to be in a period evaluation when it's going to evaluate errors, evaluate adjustment that it needs to be taken to correct the function of the machine. And then when this final and when this finish, the machine will be completely operable for all these functions. And that's be all. Thank you so much for your attention.